Right now you are on a rock hurtling through space. That rock orbits one star. Our galaxy alone contains around 400 billion stars. And astronomers have found that most of those stars have planets orbiting them. Beyond our galaxy, there are trillions more. When you add it all up, the odds of us being the only life in the universe seem almost impossibly small. So why haven't we found anyone? This puzzle has a name. It's called the Fermi Paradox. In 1950, physicist Enrico Fermi was having lunch with colleagues and asked a simple question. Where's everybody? That's it. That single question has occupied scientists for decades because it still doesn't have a clean answer. Let's understand why the paradox is even a paradox. The universe is about 13.8 billion years old. That means other civilizations had a multi-billion-year head start on us. Even if advanced civilizations are rare, a few of them spreading across the galaxy should be detectable by now. Radio waves, megastructures, probes, something should have made it to us by now. But we've picked up nothing. That's the paradox. The math says the universe should be teeming with life. Our observations say silence. So scientists have come up with a bunch of theories to explain the gap. None of them are confirmed, but each one is genuinely fascinating. Let's start with the one that might be the most humbling. It's called the rare Earth hypothesis. The idea is that complex life doesn't just need a planet. It needs the right kind of planet in the right kind of solar system with the right kind of moon. Earth sits in a narrow habitable zone, not too hot, not too cold. It also has plate tectonics, which recycles nutrients and stabilizes climate over millions of years. It has a large moon that stabilizes its axial tilt, meaning Earth doesn't wobble wildly between ice ages. It has Jupiter sitting further out, acting like a gravitational shield, absorbing asteroids that would otherwise bombard us. The rare Earth hypothesis says, when you stack up all these conditions, the odds of another Earth existing get very, very long. This is a legitimate scientific hypothesis, but it's worth noting it's not confirmed. Many scientists think it underestimates how adaptable life can be. Organisms have been found thriving in boiling hydrothermal vents in Antarctic ice and inside solid rock. So the rare Earth idea might be right, or life might be far more flexible than we assumed. Now here's where it gets darker. Some scientists have proposed something called the Great Filter. The idea is that somewhere along the path from simple chemistry to spacefaring civilization, there's a wall. Something that stops civilizations from ever becoming the kind of thing we'd be able to detect. This is where the Great Filter becomes either reassuring or terrifying, depending on one question. Where is the Great Filter? If the filter is behind us, if the hard part was going from dead chemistry to living cells, then we got lucky. The silence would just mean that first leap from chemistry to life is extraordinarily rare. But if the filter is ahead of us, if no civilization ever survives what's coming, that's a very different story. That filter could be self-inflicted, war, climate collapse, AI gone wrong. Or it could be something we can't even imagine yet, a cosmic trap that nobody escapes. The Great Filter is speculation, but it's honest speculation grounded in a real pattern. The pattern is, we look out and nobody's there. Now here's something that gets misunderstood a lot. A lot of people hear Fermi Paradox and conclude, aliens don't exist. But the Fermi Paradox doesn't prove aliens don't exist. It says, given what we'd expect, why don't we see any evidence? Those are very different things. We've been seriously searching for extraterrestrial signals for only a few decades. In the scale of the universe, that's barely a blink. We've also only searched a tiny fraction of the possible signal types and frequencies. So the honest scientific position is, we don't know. And we don't know is a completely legitimate scientific position. There's one more thing worth mentioning, because the way this gets talked about online has its own problem. Popular science content, even good popular science content, tends to frame the Fermi Paradox as a shocking mystery. The emotionally charged framing is designed to drive engagement. It's not purely scientific. The real situation is, scientists genuinely don't know and they're still actively working on it. That's actually more compelling than the mystery drama version. So where does that leave us? We know the universe is almost incomprehensibly large. We know the statistical case for life elsewhere is very strong. And we know we haven't found any of it yet. Everything else, the rare Earth idea, the Great Filter, a dozen other theories, is our best attempt to explain that gap. None of them have been ruled out. None of them have been confirmed. And the search is still going. New telescopes, new techniques, new ideas about what to even look for. The James Webb Space Telescope is already analyzing the atmospheres of exoplanets for chemical signatures of life. We've never been closer to having tools capable of answering the question, which means we might be the generation that actually finds out.